All right, let's talk about factoring quadratics using the guess and check method. Here we have 3w squared plus 17w minus 28. This method is used for quadratics that are more difficult where the a value or the lead coefficient is not 1. We have a 3 here in this case. Generally for me, I think the AC method or the guess and check method are the best ways to factor these quadratics. First things first, we know that when we factor a quadratic, if it's factorable, it'll factor into 2 binomial factors. To highlight how we do the guess and check method, what I first want to do is show you these examples over here. In this case, I have 4 pairs of binomial multiplications. I want to show you something very important about the nature of these multiplications. I've specifically manufactured each of these multiplications to have all of these things in common. The lead coefficient in each of these cases is a 3w squared, and the last or the constant coefficient is a negative 28. This is the essential piece to using the guess and check technique. It's very easy to make sure you get the lead coefficient and the constant coefficient right. When you're looking at these examples, the only difference is what's happening with the middle coefficient. I'll now break down one of these multiplications and talk about how we involve the guess and check procedure. First things first, what I'm going to do are look at the lead coefficient and the constant coefficient, or the first term and the third term in this case, and I'm going to think of all the factor pairs that multiply to be those terms. What I've done here, I'll write the factor pairs for both the lead coefficient of 3w squared and the constant coefficient here of 28. For the lead coefficient, this actually works pretty nice. Because 3 is a prime number, there's only one set of expressions that multiply to be 3w squared. More on that in a second. Over here for 28, in fact, notice that I haven't talked about negative 28. I'll involve a negative or positive here in a second, but I've written the 3 factor pairs possibilities to multiply to be 28. Now what I'm going to do is I'm going to start creating binomial sets here using these factor groups. If I involve the lead coefficients with the 3w and w, and then for the constant term, I use pairs of these numbers right here. Importantly in this case, I want a negative 28 that you'll see in a second, so I'm going to give a negative to one of these numbers. So in this example here, again, I've used the 3w and w. I'm using those because when I multiply in the foiling process, I'll get a 3w squared. When I multiply now this negative 2 by the positive 14, I will get my negative 28. So in every guess that I do, the important step is to make sure that these lead terms multiply to be your lead term of your quadratic, and that these constant terms multiply to be the constant term of your quadratic. Okay, that's the guess part. Now when we check, what we're checking to see is that if we end up with the middle term of a plus 17w, those multiplications come from this times this and this times this right here. So 3w plus 14 is 42w. Negative 2 times w is a negative 2w. This multiplication of these binomials would result in a middle term of a positive 40. In fact, you can see over here, this is the first example I put right here. Again, I've manufactured it so that I did get the 3w squared and the negative 28, but this example here does not give me the plus 17w. So the game becomes this. What I'm going to do is I'm going to continually change these values by either switching the positive and negative or switching the values until I get these 2 multiplications to give me a plus 17w. These 4 examples right here would be examples of the guessing that I would do to get this right. If I got an example like this right here, where this is almost the right answer, this when it multiplies into 3w minus 17w plus negative 28. I'm not looking for a negative 17w, I'm actually looking for a positive 17w. If this ever happens when you're guessing, the way to answer correctly is to simply swap the negative and positive right here between these 2 values, but keeping these numbers in the same place. Just to do a final check on this, if I multiply this out, I get 3w squared as I manufactured. I get a plus 21w. And then I get a negative 4w and a negative 28. To say it again, I knew I was going to get the 3w squared and the negative 28. I wasn't going to guess anything else that didn't produce those. But in this case, I have a plus 21w and a minus 4w, giving me a final form, or final checked form, of 3w squared plus 17w minus 28, meaning this is the final factored form. When learning to factor quadratics when the a value is not 1, it can be very difficult. My suggestion is to understand both the guess and check method and the AC method. The guess and check method, honestly, as you move up through mathematics and into calculus, is by far the fastest method. If you are proficient at it, you can quickly factor difficult quadratics. That said, sometimes you can get lost in the guess and check, or given really difficult polynomials to factor, can take you an incredibly long amount of time. In that way, if you ever are stuck when trying to employ the guess and check, then you could revert back to the AC method, which has a much more linear process in factoring.